So expressed as a single fraction, right? By the way, this is January 2024. We now going to start this. I saw 2 people now join you, and you all are now starting the past paper. All the time we were correcting the 2 vectors question, right? So let's go. Expressed as a single fraction in its simplest form, right? So here I want you all to do for this question. What did you all get for in the brackets? What did you all get for inside the brackets? 1 over 30 plus 4 over 15. Now, these questions, you can't use your calculator straight. You don't have to waste time working out nothing, right? So this will be 1 minus 1. What again in the brackets here? Cristiano, what again? 1 over 30 plus 4 over 15. Where get Kyle? No. Just the bracket. Huh? 9 over 30. Right? Now, this will be equal to 1. Well, 1 minus 9 over 30 will give me what? 21 over 30 as my final answer? Right. And 3 into 21 is 7. 3 into 30 is 10. So this answer will be 7 over 10. Straight calculator to calculate this, right? Okay. Questions? I see Andrew and Isaiah hand up. You all have any questions? 3 over 10. Yeah, well, this can reduce 9 over 30 can reduce to 3 over 10. So yeah, you'll get the same thing. All right, same thing. Right, so let me work. One time. B, a 2-story car park has a total of 1,020 parking spaces. At 0630 hours one morning, 1/30th of the 1,020 spaces are filled. During the next hour, no cars left the car park, right? No cars left the car park. But another 4/15 of the 1,020 spaces are filled. Determine the number of parking spaces that is not filled for the, well, filled at 0730 hours. So I want to say straight up, the time has nothing to do with this question. That 630 hours and then that 730 hours, that has nothing to do with the question, right? No. At 6:30, 1/30 of the car park was filled, then no cars left, and then 4/15 of the car park was filled after, right? Now, did you all realize that the working above here is actually that same thing? To find out the cars, yes, to find out the cars that, well, the car park spaces that are not filled will actually be, watch it, it will actually be 1, say that again? Right, no, the car park spaces that are not full will be 1 minus the 1/30th that was filled plus the 4/15th that was filled, right? So this fraction of the car park, when you work on this, will be the fraction that is not filled. And we already worked out that to be 7 over 10. So it will be, so parking spaces, so I'll put there parking spaces, yes, by 1,020. Excellent. That are not filled, right, would be equal to 7/10 of 1,020. Well, you can say over 1. And when we work on this, what we get? What we get there? 700 and how much? 14. 714 spaces. Right? Proper thing. Right? We're going on. Of the 1,020 parking spaces, 20% are on the top level. How many parking spaces are on the top level, right? So spaces on top level would be equal to, if it's 20%, it would be 20 over 100 multiplied by 1020. What does this work out to be, guys? How many spaces? Top level. How much, Cal? 204 spaces. Right? Proper thing. Right? Anybody got trouble with these? Raise your hand if you got trouble with these. This is number one, eh? This is number one, eh? Fleming, you get any trouble there? Fleming. Fleming. All right, good. So some of these spaces are reserved for monthly paying customers. The ratio of reserved spaces to non-reserved spaces would be 5 to 7. 5 would represent reserved spaces. 7 would represent non-reserved spaces. Now, when I do, you could do ratios two ways, right? You can do it in parts or you can do it as a fraction. I use parts. So 5 parts represents reserved spaces. 7 parts represents non-reserved spaces. So my total parts, which would represent all of the parking spaces, reserved and non-reserved, would be 5 plus 7, which would be 12 parts. Now, this 12 parts would be equal to 1,200 and, no, sorry, 1,020, not 1,200. So that would mean that 12 parts would be equal to 1,020. Now, those who did ratios with me, probably like a year and something ago, we did ratios. Once you find out what one part is, you can flex anyhow you want to flex, right? The mission is to find out how much one part is. So if 12 parts, this was the parts, is equal to 1,020, one part will be equal to what? I think Paula put it up there. One part will be 1,020 divided by 12, and what again? 85? 85, right? So one part is 85. They asked us to calculate the number of non-reserved parking spaces. How many parts represents non-reserved parking spaces? Would it be the 5 or the 7? How many parts? Anybody? 5 represents non-reserved? 7. Thank you. 7. Thank you. So therefore, therefore, non-reserved parking would be equal to 7 multiplied by 85. And what this gives me, my brothers and sisters? Spaces. Right? So let me pause. The cost for parking at the car park is shown in the table below. Under 30 minutes, free. More than 30 minutes, but up to 2 hours, 225, 2 hours to 4 hours, 550, 925, etc. Right? So Malik does, okay, Makila leaves the car park at 1830 hours and pays 925. What's the earliest time she could have arrived at the car park? What are we doing here? Dane, what are we doing here? Dane, what's the earliest time? Where Dane, mate? Dane. Right. How much hours would be the earliest time for 925? Look, 925 here. So it's 4 up to 8 hours. So if you want the earliest time, what are we doing? What are we minusing from this 1830? No, 925 is the money. We're talking about the time, right? Anybody want to help him? Right, so if we minus 4 hours, right, that would be the earliest time he could have reached. 8. Excellent, Nico, right? So Dane, understand it, right? Is more than 4 hours and up to 8 hours. So the more hours he stayed would have been the earlier time he could have reached, right? So if I minus the 8, Yeah, you catch it? Right. So the earliest time he could have arrived would have been 10:30 hours. Right? Okay? That's the earliest time. If I did 4, it would have been 14:30 hours, which is not the earliest time he could have arrived. Right? Next one now. Dan Raj bought a weekly ticket, parking ticket for $40. That week he visited the car park 5 different times. The length of time he parked his car on each occasion is given below. So 25 minutes and 25 minutes would have been free. And yeah. So okay, they say the show that Dana saved $8.50 by buying that weekly ticket. So we're gonna pump every one of these and see how much it would have cost for each one of these times individually. And then when we get the total, we could minus the 40 from it, and you're supposed to get $8.50. Right? So let me work. 25 minutes free. I do it right underneath here. 7 hours, 7.5 hours. How much money that would have been? 7.5 hours. Anybody have it on the scroll up? 7.5 hours. 9:25. Boom. 11 hours would have been how much? 15. 8 hours and 8 3/4 hours would have been 15 also. And 8 hours, up to 8 hours was the 9:25. Right, boom. And we added all these bad boys. So how much it would have cost? Remember this was free, yeah? 48.50. Right? So therefore, Dhanraj is the H saved 48.50 minus $40, which would have given me he saved $8.50. Soon. Right? Did you understand this? Go. So they want us to simplify this expression here, right? So we have x squared plus 7 above, and we have x squared minus 49. Now, when you have a question like this, you have to actually factorize the numerator, factorize the denominator, and then see if anything can cancel out, right? So I'm going to write it a little bigger here. It was x squared plus 7x all over x squared minus 49, right? Now, above, go ahead, Isaiah. All right, yeah, well, when we come to that, we're doing A now, right? So let's go. We factorize it. What could go into x squared and 7x? What are we factorizing out there? Anybody? Belt it out. X. Hey, bro, we on part A. You on the wrong part. We on part A. Right? So, X is what we factorizing on. Yeah. Yeah. X is what we factorizing on. Right. And in the bracket, plus, in the bracket, we would have x into x squared would give me x. And then x into 7x would give me 7. So that's how we factorize the numerator. Now the denominator is actually what we call the difference of two squares, right? So this 49 can be rewritten as 7 squared. So if you have x minus x squared minus 7 squared, let me write it out there. That's right. I will just move this here. Right. So in the next line, I'm going to express it as the difference of two squares. So I put in back the x into x plus 7 over difference of two squares will be x minus 7 and x plus 7. So what can cancel here now if we want to simplify this? What can cancel out here? Anybody? Come on. X plus 7. Excellent. X plus 7 right, cancels with x plus 7, right? So this will be equal to, x remains in the numerator position and x minus 7 would be underneath. Now, there's no way in hell you could go and cancel this x with this x, mainly because you have a minus between the x and the 7, right? You cannot cancel this. If this was x multiplied by 7 in the denominator position, then you can cancel that. But it's not x multiplied by 7. It's x minus 7. So there's nothing further we can do here. Okay, that is my answer. Raise your hand if you got this. All right, a lot of people got it. Excellent. So we go with the question that Isaiah couldn't wait to answer, right? They want us to find r when you have x to the second power multiplied by x to the 6 would be equal to x to the power of r. Now, when you are multiplying and you have the same base, you simply add the powers. So on the left-hand side of my equal sign, I'll have x to the power of 2 plus 6 is equal to x to the power of r. Now, 2 plus 6 will simply be x to the power of 8 is equal to x to the power of r. Now, anytime on either side of the equal sign, you have the same base, you can simply equate the powers, right? So, therefore, dot, 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 8 would be equal to r because you have one of the same base on either side, right? So this 8 will be equal to this r, okay? That is the value of r. R is equal to 8. Okay, everybody good there? Right. Now they want us to find s underneath here. Anybody needs to write above? So for this part of the question, we have s to the third power. S to the third power is equal to 8. All right. Now you can write 8 in index form, right? So the bracket here, I could put when 8 is equal to, 8 is actually going to be 2 to the power of 3. You all seen that? 2 to the power of 3 is what 8 is, right? So s to the power of 3 is equal to 2 to the power of 3. 2 twos are 4, 4 twos are 8. So in this case now, the powers are the same. You all see the powers are the same. So if the powers are the same, then the bases are equal, right? So it's like the next way around to what we just did above. The powers are the same now, so therefore S would be equal to 2, okay? The powers are the same, so that means the bases are equal. Above, the bases were the same, so the powers are equal, right? So this would be how we solve this question, right? Anybody actually got this? Raise your hand if you got it. Now, on to one of the easiest questions that CXC ever give in the life of CXC, right? The diagram below shows a triangle and a quadrilateral. All angles are in degrees and are written in terms of A and or B, right? So the three triangles in this triangle, the three angles in this triangle are given. The four angles in this quadrilateral are given. So for the triangle, they want us to show that 2A plus 5B is equal to 171. So I want you all to write this for me in red because I'm giving you all notes even when we are doing the past papers. So note the three angles, you'll write it. I don't care if you know it, write it. The three angles in a triangle add up to 180 degrees, right? The three angles in a triangle add up to 180 degrees, right? So what are the three angles in a triangle, my children? Let me add it up. Nisi, add them up for me. What's the first thing happened here, Nisi? Nisi.
Yes, sir.
Right, what are added? Let's go. Nissy. Nissy gone by. Shauna. Let's see why I just can't do this online thing, right? I just can't do it, man. All right, let's go. Let me do people are seeing, eh? Kyle, there we go. It's only Kyle and Cristiano in my class right now. Kyle, go. No, let me go. Let me write down the angles. Let's write down the angles. Start with one. Right, that's one angle. A plus 2B plus. All right, so I'm gonna write this plus a little better. A plus 2B, that's the first angle, plus 3B, that's another angle, plus A plus 9. And this will be equal to 180 degrees. So let's simplify. You can only add or subtract like terms, right? So this will be 1A, for those who don't know, this is 1A, this is 1A also. So 1A plus 1A will be 2A. Then 2B plus 3B would be 5B. I could fling this 9 on the side one time. And what do I do with it? When I carry there? Minus. Right? So you're minus 9. So my next line would be 2A plus 5B is equal to 171. Show. Put a little box to indicate that you did a proof. Right? Let me write that B a little better. Right? Simple as that. Okay? So those who have to copy it quickly. Now for the next one, I write down this value in one. Note the 4 angles. What angle of this? Supposed to be angles. In a quadrilateral add up to 360 degrees, right? The 4 angles in a quadrilateral add up to 360 degrees. So what am I adding here now? Right? What am I adding here? Proper. 6A plus 3A plus 2B plus 18 plus 3B plus proper thing. Right? So let me go. Somebody call it out from us. So I went out of school. Call it out there. What was the first thing? 6A plus 3A plus 3A plus 3B. You're going in order, right, bro? Right. So this is 3B. What next? Or 3B minus 2A. 3B minus 2A. Plus A what? 80. 18 plus 2B, 3B. That's it. And this will be equal to 360 degrees. Let's simplify. 6A plus 3A is 9A. 9A minus 2A will be 7A. 7A and then B's. 2B and 3B is 5B. 5B and 3B is 8B. Let's fling this 18 here one time now. So this will be 360 minus 18. Right? So 7A plus 8B is equal to 342. Box. Shown. Shown. Proper thing. Good. fine. We have to solve the pair of equations now simultaneously. Right? Anybody needs to write? So they want us to solve these two equations simultaneously. So here are we doing? You're multiplying 7 by this whole equation, right? And then you're multiplying 2 by this whole equation, right? So let me highlight it. 2 by this whole equation, and then 7 by the top equation, right? By the way, this is equation 1, and this is equation 2. Okay, so watch it. All right, put it out. It's going to be 2 by 7a plus 8b equals 342. You're multiplying 2 by everybody there, and then you're multiplying 7 by 2a plus 5b equals to 171, right? So let's work. Give me the two new equations here now. It would be 2 up. It's going to be 2 multiplied by everybody here, guys. 2 multiplied by everything inside here. And then it's going to be 7 multiplied by everybody inside here. And we're going to form two new equations. This is simultaneous equations we are doing, right? So 7 2s are 14. We have 14a. Then 2 by 8 is 16b. 2 by 342 is what? 2 by 342. Huh? You get 684, right? This will be equation 3. And then 7 by 2 is 48. 7 5s are 35b. And 7 by 171. 1197. Excellent, right? Equation 4. So I'm going to minus coming down, right? So I'm going to minus 14 from 14. I'm going to minus 16b minus 35b, and then 684 minus 1197, right? Now 14a minus 14a cancels, right? So that's why we call this the elimination method, right? So I'm going to put down the 16b, right? I don't like how I write that 6. Hold on. 16b minus, so a minus and a plus, let me highlight it. A minus and a plus would give us a minus. So I just put in minus there. And then I put in 35b, right? And this will be equal to 684 minus 1197, right? Everybody good there? Right, proper thing. I see people thumbs up. 16b minus 35b is how much be there, Cal? Negative what? Negative 19b is equal to 684 minus 1197 is negative what? 513. Right? So I'm gonna take this 19 and divide it here. Everything correct here? Andrew, go ahead. Negative 483. Somebody check over that now. 684 minus 1197. Yeah, that's okay. That's okay. You'll still get the same answer. Yeah. No, you correct still, bro. You correct. Right. So B would be equal to negative 519 over negative 19. And where you get when you divide this? What B is? Yeah, 513. Sorry. 513. Very good. Locked in, baby. Locked in. Andrew, you check it over, bro? All right. Don't worry. All of we does make them mistakes. That's why I had a check over once, check over twice, check over 3 times. Go ahead there. Kyle, you were saying something, bro? All right, nice. 27. So B is 27. I can substitute B is equal to 27 into any one of them equations above, right? 4, 3, 2, or 1. I would just do 1, right? 2a plus 5b is equal to 171. So let's go into equation 1, right? So this will be, what was 2a plus how much b? Was equation 1? Plus 5b is 171, right? 2a plus 5b is equal to 171. So I'm replacing b with 27. So it'll be 2a plus 5 by 27 is equal to 171. 5 by 27, Hitman. Wherever I get, fling it on that side one time. So 2a will be equal to 171 minus what? 5 by 27. 135? Proper thing. Carry this 2 here. A is equal to 36 divided by 2. A is equal to 18. Proper thing. Proper thing. Right. True now. So going back through it, triangle ABC, wherever C is, sorry, is 8, and then from B to wherever C is 5, right? So we're going to use our compass and ruler only. So let me go here. Right. So this is not the line you all have, but I'm just trying to recreate it, right? So we would have bang. So we call this A and B, right? A and B. Okay? Right. So this is how we do our construction. They said from A to C is 8 centimeters. So you take your compass, do this to me, put this sharp end on 0 and open your compass up to where 8 is. Everybody seen that? Open your compass as wide as up to 8 centimeters because they said A to wherever C is 8 centimeters. Raise your hand if you did this. Open your compass as wide as 8 centimeters, right? So let's work. Lead this ruler up here. So you place your sharp end on where A is, right? Put your sharp end where A is, and then you go a little above and you're going to make a big arc up here, right? So then you draw. So you're making an arc now, right? Arc. So just make an arc like this. You don't want to be too big, but you make an arc. Everybody good there? Anybody have any problems doing that? What's the length of BC? What BC was? Anybody remembers? All right, let me open it. All right, don't worry, I'll open it here. BC was 5. Yeah, 5. So I'm going back here now. This is how easy construction is, right? So this now needs to be open to 5. Measure it on a ruler, open it to 5, please. Open it to 5 centimeters. Quick work. Chelsea again, true? So I put this up. I ain't here, now, sister, what's that? Right, so we draw it now. Right. Bang. So you just want the 5 centimeter arc and the 8 centimeter arc to intersect. Right? We just wanted to intersect. So this point here now where they intersect would be C. C. So what do you think you're doing now, Kaylee? Kaylee, what do you think you're doing now to finish your sister? What do you think you're doing now, Kaylee? Kaylee, boy. What we doing now, Kaylee? Kaylee, like she like her mic ain't working. We just join lines now, Kaylee. So you draw a line from A to C, that's 8 centimeters. And then we join our next line from B to C. And this will be my triangle A, B, C. Proper thing. You should write in here was 8 centimeters. Here was 5 cm. Everybody good there? Measure and state the value of angle B to A to C. So we're going now. We're going back here now. They want the angle B to A to C. So the letter that's in the middle is where the angle will be located. They want this angle here. B to A to C. So watch it. Pull your protractor now. Pull your protractor. Right? Everybody had a protractor? You see the cross in the middle here? You're putting the cross to line up with the point A. Right? Put the cross to line up with the point A. And then you start from 0 and you're moving up. So you'll see 0 and 180 at the base here, but you're starting from 0. This is ground 0. So you start from 0 and you're going up to see how much it reaches to. What are you all getting on your protractor? How much again? Nah, something wrong. What you all getting there? 33. I get 30. Watch it. I get 30. Exactly 30. You're supposed to get exactly 30 also. That means something kind of off with everybody drawing. You have to check back your drawing. Now, when you're drawing the 8 centimeter arc, make sure that your compass doesn't slip, because if that compass slip, you will get an off reading. Anybody get 30? Any one of the 62 students here got 30? Minus I draw it over. Raise your hand if you got 30. 30 is the answer. All right, look, Charles get 30. Anybody else got 30? Okay, look, Brittany, John got 30. Chelsea get 30. So the answer would be 30 degrees, right? So angle A, no, this is BAC, sorry. angle BAC is equal to 30 degrees. And the thing about construction is everybody's supposed to get the same answer. Everybody's supposed to get the same answer. So they said the diagram below shows an equilateral triangle. If it's an equilateral triangle, that means all sides are the same. So if down here is 13, here will be 13 centimeters, here will be 13 centimeters. Something you must know about an equilateral triangle is in addition to all the sides being the same, right? All the angles are the same also. So 13 divided by 2 is actually 6.5, not 7.5, right? So here would be 6.5, right? Centimeters. Right? So right. So when you have to look at this, it's an equilateral triangle. So all three sides are the same. So if here's 13, here would be 13, here would be 13 also, right? Now, if they want us to calculate the value of each, I'm going to split this line underneath here into 2. 13 divided by 2 will give me 6.5. So this line at the base here from F to, let's call here M, from F to M would be 6.5. Now I had 7.5 here, this is a mistake. So this will be actually 6.5 squared. So all this would have to change. Delete, delete, delete. Right? Okay. So 13 squared minus 6.5 squared would be 211.65. And then we need to do the opposite of squared on the right hand side, which would be square root. So h would be equal to 211.65. It will be the square root of this. So h would be equal to 14.53 centimeters. All right? Here, Elliot. 14.53 centimeters is what h would be equal to. The diagram below shows three triangles P, Q, and R. Triangles Q and R are images and triangle P of triangle P, after it undergoes a double transformation. So they want to know, describe fully the single transformation that maps triangle P onto R. So let me deal with P onto R first. How does P move onto R? What we moving that with? What? Boom! A translation, aka slide, right? So actually slide to the right and then slide up, right? So it's a translation. That's the proper word, right? So let me write down what this is and then we'll figure out the vector, right? So the transformation is a translation. You can't put the word slide, it's a translation. Translation means slide, defined by vector. So we have to figure out the translation vector now. For those who remember this when I did it, X would be movement to the left or to the right. What topic is this under? This is under transformations. Miller, this is transformation. So X would be movement to the left or right. If we move into the left, it would be negative. If you're moving to the right, it will be positive. So let me map this here. So you're tracking one coordinate, right? Let me track this coordinate. Are we moving to the left or are we moving to the right? Left or right? Right. So your sure is a positive number on top, right? How many spaces now we want to get us here? We want to get here. So how many spaces are we moving to the right? 2. So you know the top number is 2. Boom. Right? Now we need to get up here. Now the y digit will be movement up or down. You can take a guess. Moving up would be positive. Moving down would be negative. So are we moving up or are we moving down? We're moving up. So we're moving 1, 2, 3, 4, 4 spaces up for that point to reach there. So it will be defined by vector, well, the vector 2 and 4. Proper thing, right? So the last one would be they want to know, how does this triangle move from R to Q? How does it move from R to Q? That is dog food. Reflection. We need to figure out what represents the mirror line. What will represent the mirror line here? We're looking for halfway between 2 points, right? So let me go from here to 1, 2, 3, 4. From here to here would be 4 spaces. So the halfway point would be in the middle here, right? So what is the equation of this line? 1 is understood to be here. So the equation, it's a vertical line passing through where x is 1. So the equation of this mirror line would be x is equal to positive 1, right? So I just erasing this line here, this, right? So you have your mirror line. I'm just going to put the little reflectors, right? It's like we reflected in this line, right? So let's write it up now. So the transformation, is a reflection. Now, anytime it's a reflection, it will be in the line. In the line, x is equal to 1. That's the equation of the line that would form our mirror line. So we completed the 3 questions. I'm going to send this past paper along with the worksheet. You all can try it in advance, no problem. But we will be correcting as much questions as we can in the next class, right? So thank you for being here, guys. Class today was excellent. We have 62 people online. Excellent class, right? Proper thing. My internet terrible where I'm right now, so I would not be uploading any videos and any worksheets until tomorrow when I go back down LC Kuro, right? So take care of yourself, guys.